We divide all the classes into one of three camps: the model camp, the controller camp, or the view camp. And how do you decide what goes in each of these camps? Well, the model is essentially the what of your program. What is your program? So as we're doing this MVC talk, I'm going to talk about our first application we're going to build, which is a card matching game. Okay, so we're going to build this game. It's got a bunch of cards on the screen, like playing cards, you know, ace of clubs and all that. And you're going to be able to go choose the cards, and you'll get certain points if they match, like the suit matches or the rank matches or whatever. You get more points, less points, whatever. But you're doing that. In that kind of application, a little card matching game, the cards and the deck and even the logic for how the game is played are all UI independent and in the model. Okay? So how the cards get drawn on screen is the job of the controller. So the controller is its job to figure out how am I going to take this set of cards and display them on screen and then animate their movement and things like that. Okay, that's up to the controller. So the controller controls how the model is presented on screen. And the view is the minions, the classes that the controller is going to use, kind of like the building blocks, the Lincoln logs. I don't know, maybe that's before all of your time, but you know, the things we're going to do to build our UI, we're going to use in the view. So the stuff that's in the view is pretty generic, okay, generic UI elements. The stuff in the controller is very specific to how your UI works, and the stuff in the model is completely independent of how your UI works, okay? So doing MVC right is about knowing where things go, but also about how to communicate between these three camps. And so I'm going to try and summarize how the communication works between these camps. And I've used road markings. You see the double yellow line and then the dashed white line. So that's like you're driving in your car. Try to use them as I have an image for how this communication happens, where it's allowed, where it's not allowed. Okay? So let's talk about the controller talking to the model. Okay, well, going from that side of the road over to the model side is a dashed white line. In other words, you can head right across there. Probably want to look before you go, but you can go right across, okay? The controller has to know everything about the model, and it has to have complete ability to talk to the model, use its public API as much as it wants, because the controller's job is to present the model to the user using its view as its minions. So it has to have this access. So that's full unrestricted access the controller has talking to the model. This is a one-way error, one-way arrow from the controller to the model. And similarly, from the controller to the view is also unlimited communication, because the controller is responsible for using its own minions. The view is the controller's minions to lay out the user interface and all that stuff. So the controller can do anything it wants. I've put that little green word outlet up there because when we have a property of a controller that points into the view, we call it an outlet. Okay, and you're going to see that in the demo on Wednesday. I'm going to say, oh, let's create an outlet from our controller to our view so our controller can talk to its view. All right? What about this communication? Model to view? Never. And why is that? 100% obvious. The model is completely UI independent. So there's absolutely no way it could talk to a view object or anyone in that camp, because the view objects are fundamentally UI objects. They're kind of generic, but they're still fundamentally UI objects. Similarly, since the view objects are kind of generic, they can't be talking to any specific model. They need a controller to interpret a model for them. Okay? So there's never any communication this way. That's why it's a double yellow line. That's why these lines are red. That's why there's fire. Okay? Never go across that line, ever. What about the view talking back to the controller? You got these generic view objects like buttons. Can they talk to the controller? Well, yes, they can, but they have to be careful because the view objects are generic. So they can't really know much about the controller. So they can only communicate back to the controller in a blind way, where they don't know the class or the thing they're talking to, and in a structured way, a way where we all agree we're going to communicate this way between the view and the controller. So what's an example of a structured way? Well, one is called target action. So the controller basically drops a target on itself, and then it hands out an action, which is like an arrow, to the view, and says to the view, okay, when you do what you do, like you're a button and someone touches you, or you're a slider and someone moves you, send me that action. Okay? So in this way, the generic button or slider is communicating back to the controller. It has no idea that it's a card game controller or a space game controller. It doesn't know what kind of controller it is. All it knows is that when something happens in itself, boom, it sends a message to the target. So that's a blind, simple, structured way for the view to communicate with the controller. Okay? But what about more complicated ways? Sometimes the view, things are happening in the view that are somewhat complicated, and the controller needs to be informed of what's going on, synchronizing what's happening. And one way to think about this is these words I've put up here, will, should, and did. When the view is kind of like, let's say I'm a scroll view and I'm scrolling around, and I want to let the controller, somebody, know that the user just did scroll. Okay? Or the user puts down the touch and is about to scroll, I want to let the controller know the user will be scrolling. Okay? Or the user puts the touch down and the scroll view wants to know, should I allow the user to scroll here? Is that allowed? All those things, the scroll view itself might not have enough logic to know the answer to those questions. So what it does is it delegates the authority to answer those questions to some other object. Now, it doesn't know the class of that object. All it knows is that other object can answer these questions: will, should, did, this, that, or the other thing, like should allow scrolling, did scroll to point, things like that. So those are the kind of methods you're going to see in these delegate protocols. Now, I know that CS106A and B do not teach protocols. The word program. How many people know what the word protocol means in object-oriented programming? Okay, see, very few of you. So I will be teaching that. A protocol is just a blind way to talk to another object. You're going to, when I teach you, you're going to be like, oh, yeah, I know what that is. So we didn't really call it protocol or whatever. But that's how we do delegation, okay, this blind communication. Also, another important thing is that views should not own the data that they're displaying. They should not own it. In other words, it shouldn't be a property inside of them where that's the truth of that data. And the easiest example for this is all the songs in your iPod on your iPhone or your iPad, right? You might have 10,000 songs in there. So if you have some kind of generic list view in your view, you can't transfer all 10,000 songs to its instance variables and expect it to hold 10,000 songs so it can list through it. A, that would be inefficient. And B, that information, those 10,000 songs, belongs where? In the model. Okay, because your song database is a model. It has nothing to do with UI. It's just a list of songs and artists and albums and all that. It's in the model. Some controller has to look at that database and tell a view how to display all those songs. Okay, so we need that communication to happen here. And the view is displaying some sort of list, and you're touching down and you're flicking on the list and trying to see more songs. How does that communication happen? And the answer is we have another special kind of delegate, which we call a data source. Now, the data source doesn't do the will, did, should. It's going to be asking questions like count, like how many songs are there? And the controller looks in the model, 10,000. Response to the view, there's 10,000. The view makes space internally for 10,000 things. It doesn't know what they are, moves the scroll bar indicator a little bit so that you know where it is. And then you start scrolling, flipping through it, and it starts sending the message to the controller, give me the data at line 150, next 10 items. You see what I mean? And then you flick down some more. Now it's saying 250, 10 more items. And so the controller is going back to the model and saying, give me more data, and it's providing it to the view in this blind way. So see how the view is getting data from the model through the controller in this kind of blind, structured way. Okay? That makes sense to everybody? So data source is just a kind of delegate. It's a specific kind of delegate for getting data. So you're going to see that there are classes in iOS that have a data source, and they usually also have a delegate. Most sophisticated classes in iOS have a delegate, the will, did, should kind of things. Some of them have a data source. It depends on whether they're showing a lot of data or not. Now, simple data, like if I had a view, if I invented a view for my card game called playing card view, and it just has a suit and a rank, okay, we're not going to do count data at for just suit and rank. We are going to set those properties. And so the view then would have that data set in it, but it wouldn't be owning it, right? The model would still be owning the suit and rank. The view is just getting that data to present it. Okay, so simple data we might transfer to the view, but it's merely for it to display it. Okay, this all adds up to the controller's job being to interpret and format the model data for the view. That's the controller's job. And when we do our demo, I'm going to be remarking like, oh, see, I'm writing this code. This is to make the controller perform its job, which is to take the model data and put it in using its view minions, put it on screen. Okay? That's what the controller does. What about this communication? Can the model talk to the controller? Again, obviously that's verboten because the model knows nothing about UI, so it couldn't possibly talk to a UI object like the controller. But sometimes things change in the model, and the controller needs to know about it. Okay, data changes, a database changes, or the model is some network database, and somebody changes something on the network, and it changes, and the controller needs to find out. So how do we do that communication? We do that using kind of a radio station model. Okay, so the model, a radio station concept, the model will use this concept to essentially broadcast information to anyone who's interested. Okay? And the mechanisms for doing this in iOS are called notification and key value observing, KVO we call it. And so the model can just say, oh, anytime something changes in my model, I'm just going to broadcast on my radio station. And then the controller simply tunes into that radio station. And it can find out things are changing. And when it finds out something changes, it's going to communicate via its green arrow to the model and say, OK, give me that data that changed. Right? Does that make sense? So towards the end of the quarter, we'll start seeing a little how to do notification to find out, for example, if the data in a database changes. We'll get a notification. The UI can then, controller can then go talk to the model to get the info. Okay? Some people have asked, can a view tune into the radio station? They probably could, but you probably wouldn't want to do that. That would probably be a violation of MVC. All right, so we do this. We have all this nice communication and all these rules. And we can imagine building something simple using this. But what if we want to build a big, complicated app? An app that has multiple screens on our iPhone or on an iPad. It's got, 3 or 4 different areas on screen where things are happening. How do we do that? Well, we're essentially going to combine multiple MVCs, okay? Because an MVC can use as part of its view another MVC, okay? So an MVC, an entire MVC, can be one of the minions of some bigger MVC. Okay? And by doing that and cascading it down, we can build more and more complicated applications. So an example of this is you might have your calendar app, and it's showing you the entire year. And you click on a month, and now it shows you a month view. Well, a month view looks a lot different than a year view. A month view just has all the days and maybe some circle that tells you where you have an appointment on a day. And then maybe you click on a day, and now you get a day view. Okay? And the day is showing you the hours and what all your appointments are. And you click on an appointment, now you get an appointment view, and it's showing the detail of where you're going and when it is, et cetera. Okay? Well, each of those views, the year view, the month view, the day view, and the appointment view are their own MVCs. Okay? But you can see how the last 3, okay, are used as essentially a minion of the top level view, the year view, to show more detail. Okay? So the year view, you click on a month, it's going to use the month view MVC to show more detail. So it's part of its view. Okay? So you see this also in iOS with tab bar controllers, right? You have the tab bar at the bottom might have 4 or 5 things you can choose. Well, there's some MVC at the top has 4 pointers to 4 minions, which are the 4 MVCs that are each going to appear in a tab bar. Okay? And we'll be doing that, for example, in assignment number 2 or 3, where we'll be making a tab bar, and you're going to have to do multiple MVCs. Okay? So that basically results in a picture that looks kind of like this. All right? Where you got this MVC, and you see the purple one that's like underneath the word together there, and it points to 3 other MVCs outside of its view thing. Okay? That's how we're going to build. So that might be a tab bar controller, and those might be the 3 tabs. Okay? And each one is its own little MVC, completely independent, operates on its own, doesn't even know. It's a generic, usable, reusable view-like thing at this point. Doesn't even know that it's in a tab bar. Okay? It just knows it's supposed to do whatever it does. And so it's modular in that way. You can also see that there's no communication between any other